So I'm actually happy also that all the speakers agree to participate in this event. This is actually the second talk of the BCI Thursday this year. And like, you will focus actually on the ethics part that I think is one of the main topics now, since like the BCI is becoming always more present also in the news and I mean in the general knowledge of the people. So now there is still like the problem of the ethics is some urgent problem actually. So before starting with the talks of the two speakers of today, Victoria will actually introduce a new initiative of the BCI Society during the BCI meeting of next year that will take place in Banff. And like, I don't know, Victoria, if you want to start, maybe we can wait a bit, another minute, so see that all the people are in, maybe. Yeah, that should.
You prefer. I'm happy to wait. I'm happy to start.
Yeah, no, I think that we can go, basically. Yeah.
Okay. So I will start like thanking Valeria and the two speakers of today, like Thursday event, because they allow us to, in a way, stall some minutes, because we want to introduce to every one of you this new initiative that is an initiative from the membership committee of the BCI Society that we call it Global BCI Session. And it's something that is going to take place at the upcoming 11 International BCI meeting that I hope to see most of you there in Canada. So my name is Victoria Peterson. I am from Argentina, and I am part of the membership committee. And the idea of these minutes is to introduce everyone about this initiative and to, in the best case scenario, you can apply or you know someone that can apply to this initiative. And the reason why we create this initiative is because there are a lot of stuff that motivate us. First, we know that BCI is an active and really growing field around the world, but nevertheless, the density of the researchers are still in the north part of the world, like North America or Europe. So we know that, like me, I am in Argentina, there are a lot of people working in different countries, and we understand that diversity is important for the improvements and enhancement of the field itself. So also something that, for example, I do know by myself, like being able to attend international meetings is complicated, is really hard. Not only, I mean, because of economic restrictions, is one of those, but it's also, it may be one meeting that we are able to attend in every another year. That's the reality. And it's important to attend this meeting, not because we just, of course, we are gonna learn about the last funding and cutting-edge research that is happening in the area, but also networking and partnerships is really important. We know that, but it's even more important when you are conducting research in a low or middle income country. So since we are aware of this, we wanted to support. So what we expect by this initiative is to support, enhance, but also to showcase all the BCI researchers that are conducting research and also are from low or middle income countries. And we want to extend it across the world, across the globe. So we really expect that we can enhance diversity in the society and, of course, in the upcoming BCI meeting. So what is this about? This is a session that is going to take 1 hour slot in the main program, and it's divided into two parts. So the first part is actually the speaker showcase, where the selected speakers are going to present their BCI work, current or past, but what is important is to highlight the different socioeconomic challenges that maybe they had faced. But it is important because that gives me to the second part, that is the roundtable discussion, at which, by means of a Q&A section, what we want to do is to promote awareness of those difficulties that can be, really not really seen by other people when you know how our social economical restrictions are constraints. So we are willing, everyone can apply, but that everyone is actually, the person should be an early or senior researcher, like postdoc or any academic professor, must be member of the BCI Society or must become a member before the start of the meeting. Researchers should be and should conduct their research from low to middle income countries, and we rank them according to the World Bank country rank. And please be aware that this World Bank country bank, for example, rank Argentina as an upper middle income country, and I don't know what, but Latam countries are like upper middle, but everything in between low and middle is this category that we're thinking of. And importantly, we are seeking researchers that has experience at least in 5 years of BC. And from those selected, from those candidates, there are going to be a selection committee, and the selection is going to have different consideration while doing so. But most importantly, we are going to think about gender parity. So the way we are going to support these researchers is by waiving them the registration fee for the upcoming BCI meeting. And also we are going to support them by giving a restricted amount of travel support for them to assist in person to this event. So if you want to be part of this, or you know someone that can be part of this new initiative, and that will be the first BCI global session that aims at support, enhance, and showcase researchers for low to middle income countries, please help us to spread the word. That QR is actually directing you to the website of the BCI Society, where all this information is also there. But most importantly, there is a Google form that all candidates should complete before the deadline, that is soon, in November the 16th. So that's all from my part, and I'm happy to answer any question if there is any for the audience. But yeah, the most important thing is that you help us spread the word, or if you think you can apply, please apply as soon as you can.
Thanks a lot, Victoria, and thanks also to organize this important, so to introduce to the BCI meeting this important session. I think that actually it would be really interesting then at the BCI meeting to see which are the most critical aspects in each country. So I think it will be super interesting then in June to see what people will bring there. So thanks a lot.
Thank you.
So now we can move to introduce actually the two speakers of today, Marcello Ienca and Susan Boehnke. I hope that I pronounced well your surname, even if I asked also before. But Professor Ienca, he is like a professor at the Technical University of Munich, and he's an expert in ethically sustainable development of AI system and BCI. And whereas Susan Boehnke is like the lead of the training committee of the Connected Minds. I think she will also explain a bit what is Connected Minds and how they actually would like to develop a socially responsible technology environment, and so also to create connection among researchers to do so. So I will actually leave the floor to Marcello, so that can maybe share your screen and we can start with their talks.
Sure. So thank you, Valeria, for the invitation and for the kind introduction. So I'm going to share my screen. Can you see it, or do I need to flip screens again?
No, it's perfect. Thanks.
Excellent. So my presentation will attempt to provide a sort of as comprehensive as possible overview of ethical issues emerging in the context of BCI research. Of course, I need to say up front, this list is not going to be exhaustive, so there might be ethical issues that are more pertinent to the research of people in the audience, and the fact that they're not included in this list doesn't mean that they're secondary. It's just that in the interest of time, I wanted to focus on some of the emerging issues that we faced in our own research that are quite relevant. Of course, I don't need to explain to this audience what a BCI or more broadly a neural interface is. Just for clarity, for definitional clarity, I just want to say up front that I'm going to stick to the Royal Society definition of electronic devices placed on the outside or inside of the brain or other component of the nervous system to record or stimulate activity or both. And it's precisely this dual dynamic of recording from the brain and influencing the brain through neuromodulation and neurostimulation that is going to be at stake in my presentation. Also, we have with Davide and Francesca Santoro, I see Davide was in the audience before, we have a paper that attempts to kind of delineate the ethical present and futures of BCI. So some of what I'm going to refer to today is in the paper. Okay, so the first challenge that I really want to start the discussion with is the problem of adequate translation of BCI to maximize human well-being. And the reason why I want to start with this is that for many people, ethics is the discipline that intervenes when things go wrong in neuroscience and neurotechnology. So neuroethics is about flagging problems in neurotechnology or neuroengineering development and trying to address a sort of a priori compatibility between research designs and predetermined ethical values. And I really want to challenge this view of ethics, which I think it's very restrictive. It's based on a negativity bias that has been largely introduced by my fellow ethicists as well. So typically, we also tend to share this view that ethics is about the prevention of harm in the context of neurotechnology, but in reality, ethics, neuroethics in particular, and neurotechnology innovation have a shared goal, which is that of maximizing human well-being and making the life of people better. And to do so, we need to have an adequate translation of neurotechnology innovation for the benefit of many. Because if we have introduced obstacles that slow down or delay or even inhibit the development and adequate translation of technologies that could benefit people in need, people with neurological and psychiatric disorders, then this is not a neuroethically neutral stance, but actually a detrimental one that could cause suffering or avoid the prevention of suffering for millions of people worldwide. And of course, we live in exciting times where new neurotechnologies are being developed that can massively help humanity. Just to make a couple of examples, the kind of brain-to-spine interfaces that people like Grégoire Courtine and colleagues are developing at the PFL to help people with acquired spinal cord injury to regain lost motor function, as well as in the context of speech BCIs, the work of labs like Ed Chang's and many others to develop high-performance neuroprosthesis that could enable synthetic speech for people with aphasia, such as this patient with ALS. Now, these technologies are experimental, so in order to translate them into clinical applications for the benefits of patients, we need to have adequate clinical translation. And it is a responsibility of neuroethics and neurotechnology policy to make sure that we remove all the obstacles that prevent that clinical translation. The second issue that I want to discuss here is AI integration. So BCIs rely increasingly on artificial intelligence to enable functions such as feature extraction and classifications, especially closed-loop architectures rely heavily on AI. We need AI for data analysis because AI algorithms can help us identify correlations and anomalies in the data. They're very useful for pattern recognition purposes and also for neurofeedback, so for providing real-time analysis of brain activity in neurofeedback applications. And also on the writing into the brain part, so in neuromodulation and neurostimulation applications, AI is proving very helpful to optimize stimulation parameters, to help us in targeting specific brain regions with higher precisions and therefore reduce the risk of unintended effects, and also to enable closed-loop architectures that continuously monitor brain activity and adjust the stimulation parameters accordingly. So AI is extremely helpful, but at the same time, as we'll see later, there are some AI-specific ethical issues that remain unaddressed, related, for example, to algorithmic bias that could be present in the training data sets and can lead to automating differential outcomes of BCI applications across different groups of people. And in general, AI also seems to be something that the general public is particularly concerned. This is some yet unpublished results from sentiment analysis studies that we're conducting with a PhD student of mine, Alex Sobieska, and we are doing a big data analysis of the neuroethics discourse on online platforms, especially social media, and what's emerging from analyzing several millions of videos and associated comments is that the majority of the population is particularly concerned about the ethical implications of incorporating AI features in BCIs. Whether this is justified or not, it's a different question, but we need to be mindful that there is a particular public concern with regard to this. So what you see here, it's a heat map that measures different levels of ethical concern in association with specific topics. The third issue that I want to discuss with you today is mental privacy. This is a long-standing problem in neuroscience. I guess the older among us still remember the so-called mind-reading problem that was ignited in the 1990s as a consequence of advances in fMRI. Now, with the combination of BCI and machine learning, we are seeing this debate being interestingly revamped. So there are two types of mental privacy issues that can be associated with processing data from BCI applications. One is the problem of re-identifying people who want to remain anonymous. This is something that has not been proven as feasible in BCI applications yet, but we have some interesting studies such as this one that show the feasibility of re-identifying anonymous research participants from structural MRI studies by combining the data set with face recognition software. Of course, they were not using masking features in the software, but still, I think this is an interesting development. But of course, we also have the mental privacy problem in the stronger sense. So not just re-identifying people from an anonymous data sets, but also reconstructing the content of mental states, potentially in a non-cooperative way, through a process that Russ Poldrack has called reverse inference. So we reason backwards, so to say. So we start from data sets of neuronal activation to infer the specific engagement of mental processes. And this is a line of work that has been pioneered by Jack Gallant in Berkeley, among others. And now we see quite interesting developments associated with leveraging AI models in the context of reconstructing mental states from neural activity. So this is the work from Shinji Nishimoto in Osaka. who use stable diffusion to reconstruct visual content from mental states, which with a quite remarkable level of sophistication and reliability. Other labs like Alex Huth in Texas are using large language models to achieve similar results. In particular, they use the GPT-1 paradigm to enable semantic reconstruction of continuous language from fMRI data. The study is from 2023. The data were collected in 2022. GPT-1 was the paradigm available at that time, which is based on 117 million parameters. Now, in 2024, we have GPT-4, which is based on 1.76 trillion parameters. So just to give you a comparison of the difference between these two models, if you have 117 million 10 years banknotes and you stack them together, you can cover the distance between Beijing and New York. But if you have 1.76 trillion banknotes, you can cover the distance between Earth and the Moon and back 609 times. So this shows that the potential of AI models to process neural data is growing exponentially. Of course, increasing parameters doesn't automatically correlate with increase in computational reliability, but it certainly correlates with computational power, and therefore with potential increased readability of the data. The fourth challenge, the second last, is the problem of manipulation, especially in the context of extra-clinical applications of BCI. As we all know, BCI originates as a research technology and as a clinical technology, but now we have an ecosystem of BCI applications outside of the spaces into the consumer market. We have plenty of technologies of companies that produce direct-to-consumer BCIs for purposes such as entertainment or self-quantification or device use. Of course, there is nothing ethically wrong with having BCI technology used outside of the clinical and research domain. But of course, this brings additional ethical and regulatory challenges because the clinical domain is very strictly regulated, whereas the consumer space is very poorly regulated when it comes to BCI applications. And therefore, there is a possibility that companies may want to use data obtained through consumer BCIs for purposes such as psychographic profiling, which, as many of you know, is the standard business model of the social media industry and more broadly, the data economy that we're part of. So we have to be mindful that consumer-generated BCI data are potentially a big asset for the data economy, and there can be a big appetite for this kind of data. I'll skip this in the interest of time, and I want to address this two last issues which relate to impact on agency and psychological continuity, and then the issue of abandonment, which are quite connected. So impact on agency and sense of self, it's still a big question. So it's an empirical question that we haven't resolved. As you can see here from this meta-analysis done by Gilbert, Viana, and Inechen, there is an increase in studies that report effects of estrangements or modulation of the sense of agency as a consequence of BCI use, as a side effect of BCI use. But many of them are conceptual studies, and primary research is still very limited. So the jury is out with regard to whether certain BCI applications can induce modulations of the sense of agency that are kind of bypassing the intentionality of the user. But we need more studies to address this. And probably we also need to standardize how we actually conduct studies in this domain in order to verify and to measure this during clinical trials. And finally, the issue of abandonment and undesired explantation is an emerging issue. This is something that we covered in our own research with Fred Gilbert and Mark Hook, reporting the case of an Australian woman who was using an intelligent BCI application for predicting epileptic seizure from a US-based company called NeuroVista. NeuroVista went bankrupt a couple of years ago, and as a consequence of that, they could not ensure maintenance of the implantable device. So this woman, Rita Leggett, was left with no option but having the device explanted, because otherwise the risk of infection and malfunction would just be too high. So the device was removed, but it was removed against her will. So she, of course, signed an informed consent form, but she didn't want the device to be explanted because she was very happy with it. It was giving her an increased sense of safety, and therefore this unwanted explantation had a negative impact on her psychological life. She even reported effects of traumatic harm and agential discontinuity. So discontinuity in her sense of agency induced by the explantation of the device. So again, this is a single case study. We need more research in this domain, but the issue of abandonment needs to be taken very seriously in order to protect the rights of BCI users. And in the 3 minutes I've left, I want to conclude with something constructive and attempt to delineate how these challenges can be potentially addressed and how a converging ethics for BCI can look like, and propose a pathway towards responsible integration of AI into neural interfaces that consists into 4 steps. The first one is alignment of neuroethics and AI ethics. So many of the issues that we're now facing in neuroethics with regard to AI algorithms being biased, or the problem of training data, or the issue of amplifying effects through automated processing. These are all issues that the AI ethics community has been discussing for years. So we need to capitalize upon that. We don't need to reinvent the wheel. And to do so, we need an alignment between neuroethical standards and AI ethics standards. So in our own work, we did a meta-analysis of AI ethics guidelines, and we found out that there are plenty of guidelines out there that have been developed. I think it would be extremely helpful if the in-development neuroethics guidelines will adhere to this AI ethics guidelines. The second constructive suggestion is expand our validation and assessment paradigms. So BCI clinical trials are still to a large extent based on the research ethics model that we develop for drugs, for pharmaceuticals. So we typically assess risk in the form of biomedical and socioeconomic risk for the research participant. However, we need a greater, more holistic consideration of psychological risks in the form of effects on the sense of self and the phenomenological dimension of the user. But most importantly, we need standards for data processing and algorithmic risk, because we currently do not have a system in place to address data-related and algorithm-related risks in the BCI validation process. And I see we have in the audience Judy Illes, who is the lead of the International Brain Initiative. I'm in the neuroethics working group at the IBI, and what we're doing there is precisely to try to develop a framework for addressing data-related and algorithm-related risks in BCI applications to ensure a safe introduction of AI systems and automated processing via AI in neural devices. The third constructive suggestion is to leverage AI not just to optimize function, but also for risk mitigation. So there are plenty of AI-based privacy-preserving technologies, such as secure multi-party computation, homomorphic encryption, that can help us make our BCIs more secure. And also we have explainable AI models that could be implemented in BCI applications to ensure their trustworthiness and explainability, so that the devices are amenable to post-hoc and ex-ante inspection. And finally, human-centered research is critical. Again, I see in the audience Jan Burkert, who's a BCI pioneer, and we had a session about the importance of BCI human-centered research at the last INS annual meeting in Baltimore. But in order to do so, we need more patient-centered research. So a lot of patient-centered research, especially in the field of neuroethics, was based on small studies. So we need larger studies. And with some colleagues in Canada, actually, and Switzerland and Germany, we're attempting to do so. So we are now collecting more than 100 interviews from various BCI users across the world to understand their subjective experience, and also to collect feedback, sort of human-centered requirement analysis for the design and development and successful implementation of these technologies. Data are still unpublished because the study is still ongoing, but some interesting patterns are emerging that I'm happy to share with you already. For example, the majority of DBS users tend to perceive the activation of the DBS as a necessary component of their new sense of self, and the deactivation of the device as a sort of deactivation of the self, which is also reflected in the way the phrasing of this patient reports. And also what is interesting here is that the majority of patients believed that an implantable BCI should be considered as part of the self, with the very important ethical and legal consideration that if the device is removed or disrupted exogenously, this would correspond to a personal assault and not as a harm to property. And finally, I want to conclude with what kind of, in my view, future research is needed. So we need a better standardization of validation of safety assessments. We also need to develop quantitative and qualitative metrics for subjective parameters. This is a study that we've done with Giacomo Valle, who we'll also see in the audience, and Stanislas Popovic. It will be forthcoming very soon, I hope. And also we need more cross-cultural perspectives, because most studies in neuroethics are coming from the West, but we actually need more cross-cultural perspectives, because different cultures across the world have different views, and we need to be sure that the ethics frameworks we develop are sufficiently pluralistic. And last but not least, I think neuroethics needs more experimental research. I think the time of armchair ethics is long past. We need to validate neuroethical stances at the normative level, also with the help of experimental studies that can help us understand some critical problems in the neuroethics space. So I'm stopping here and thanking you all for your attention. So I'll stop sharing. Oops.
Valeria, you're muted.
No,
Sorry, I'm muted. Sorry, thanks. So actually, Marcello, thanks a lot for your presentation. I was saying that actually, I think that you really pointed out some crucial aspects of the neuroethics and neuro rights, in particular with the implantable device and how they are perceived by the patients in clinical application, and also then for in the human in particular with the trend also that is coming for on BCI, that is always more common for also not only clinical application. So, I mean, I think that we can go on with the Susan presentation, and then we have space for Q&A at the end. Okay, so the floor is yours, Susan. Thanks.
Great. That's right. Got this. Is that working?
Yes, it's
Yes.
working. Yes, thanks.
Perfect. Well, thank you so much for inviting me to be part of this. And it was so nice to meet Professor Ienca, someone I've only known through his incredible repertoire of neuroethics articles, some of which I even cite in my talk. And I just wanted to know, I'm a basic neuroscientist, and I've shifted through the pillars of neuroscience, including finding my way into neuroethics. And so I wanted sort of, especially because I know there's a lot of trainees in the audience, but encourage you to also do so, to collaborate with neuroethicists and not to be afraid. I really appreciated that you talked about that negativity bias. And certainly back, 10 years ago when I first started thinking about neuroethics, a lot of neuroscience colleagues would have said, yes, oh, the neuroethics, they're like the police or something of our research. And I think we really need to get away from that. And we do that, I think, by integrating neuroethics early. So I'm going to talk about transdisciplinary approaches that I'm taking to neurotech training, where we, the idea is bring in people with the engineering and the neuroscience, but integrate neuroethics right from the get-go so that this is part of their practice. So I know anybody here knows the history of BCI, and that, of course, that history didn't start with Neuralink. Phil Kennedy was doing this in the 80s, about the same time that cochlear implants were coming into use, and DBS devices for Parkinson's were being implanted. And of course, this accelerated in the last 10 years dramatically with the advent of all these brain-computer interface companies, and of course, the consumer neurotech. And I found that this was really capturing the attention of my students. And there was student clubs popping up. There was a huge interest. And I wondered, how do we do a better job of educating them on these? Of course, when you have this kind of change, neuroethical issues arise. I won't belabor this because Marcello took us through this already. But of course, we have this issue of device abandonment as just one I want to highlight. And this is a great example. There's the case of Second Sight, another company that went bankrupt and left a whole bunch of retinal implant users in a lurch because they couldn't actually get their implants removed, upgraded, or repaired. And who is responsible for that? And how do we prevent that kind of situation from happening in the future? And of course, there's the issue of how brain implants like this potentially are changing and are merging with people in a way that they become part of their identity. And I like that you highlighted that with Parkinson's patients with their DBS devices, that this really has become their sense of self really changes depending on their settings or whether it's on or off. And of course, I'll just highlight the case that you described of the epilepsy patient who had merged with her device. It's a fascinating case study that you guys described. Of course, alongside, there's also this history of neurotech has been, deliberation about the neuroethics. And this goes way back. It's not something new, but I mean, you can look back at Judy Ellis's review in 2006, where they were already outlining the history of neuroethics. And of course, it's just continued to accelerate. And now we have major organizations like the OECD and UNESCO and the IEEE all putting out frameworks and recommendations for responsible innovation in neurotech. In fact, the OECD has now been 5 years since all the countries signed on to that, and now countries are having to come back with how they've socialized these in their jurisdictions. And for example, I've been delighted to have been part of a team that was working to go through these and think about how they resonated with Canadian culture and what our guiding principles for responsible innovation in neurotechnology would be in Canada. So I want to tell students about just sort of my path to becoming a transdisciplinary scholar, because I think transdisciplinarity is the way that we break down these silos in our neuroscience, in engineering and tech development, and in neuroethics. And if we start to meaningfully talk between these fields, join forces in research projects and training, then we can make a lot more progress. So I started off in basic human perception. I took a little stint to work in industry, which people always think is interesting, and then went back to do a PhD in neuroscience, transitioned deeper and started doing monkey neurophysiology studies. So I had a lot of experience recording from neurons deep in the brain. Then went even deeper into molecular biology and biochemistry, and started working on the development of primate models, which come with their own ethical considerations. And around this time, I started doing an awful lot of undergraduate teaching and realizing that it really was beneficial to our undergraduate students to have the neuroethics interweaved as we introduced the topics. And I started teaching about these developments that were happening over the last 15, 20 years in, say, neuromarketing and other ways that neurotech was being used in society, and getting them to think about these issues early. So how is my path to neuroethics? Well, I have to say, it came as I was of that era of neuroscientists where it felt like there was probably a negativity bias, but I had become interested and had started reading papers by people like you, Professor Ienca and Judy Illes and others. And I thought, well, I'm just going to go to a conference and I'll just see what it's all about. And little did I know that it wasn't just sitting and watching some talks, but it was an active workshop where I was fully integrated in the process of co-creating research around. In this case, it was looking at the legal implications of neuroprosthetics for speech, because this was right in the early days of when work from Eddie Chang's lab was coming out. And this then turned out that it was actually quite useful to have a neurophysiologist participating in these deliberations, because I could actually read these papers in depth and explain some of the methodological issues. And we were able to then publish a couple of papers related to the ethical, legal, and social issues that might emerge from the decoding of speech from the brain. So the other thing I was doing was co-teaching neuro law sessions with a law professor from our university who was also interested in neuro law issues. And that was extremely interesting. And she said, there's also people in our surveillance studies center over in sociology who are also interested in issues related to neurosurveillance. And I thought, well, why not put everybody together in a conference so we could actually meaningfully discuss these issues in a truly transdisciplinary setting? And so we got funding from our research council to have a conference, which we titled A Neurotech Future, Ethical, Legal, and Policy Issues. This was a fascinating event held in the early days of COVID. And we had a number of workshops where we talked about how do we really do new training programs for this neurotech future. So we sort of thought about what skill sets might be required. Obviously, we would need to teach the engineering, the materials and electrical engineering and underlying how we record from the brain. We would need to teach the neuroscience, but we'd also want to integrate right from the get-go ethical analysis and considerations of how these technologies were influencing society. And also we had a lot of people that would be interested in actually creating companies, but maybe they needed to better understand regulatory affairs, which is actually very poorly taught. And so I thought, well, maybe we could create a program just by collecting different courses from across our institution. And that was just clearly not going to work. The silos are so ingrained in our universities, it's very difficult to break them down. But we decided because a funding opportunity came up where the province was funding micro-credential programs for emerging industries, we actually said, well, maybe we would have to make these courses from scratch. So this is where we started creating our new neurotech micro-credential program, which we've been piloting this past year. So these are a series of micro-credentials. They're online and asynchronous, open to anyone in the world. And we've had a number of students enroll in this one and the neuroscience and neurotech primer, which is sort of our neuro introduction. But we also have our hardcore neuroengineering course, neuroimaging, and we have forthcoming soon our ethical considerations in neurotech course and neuroentrepreneurship. And there are more to come, including one specifically dedicated to BCIs. And what was surprising, because I made this for Canadian undergraduate students, I thought, is that in fact it was being taken up by more than half from outside of Canada, including a lot of non-students, which was a fascinating development. People from industry looking either to transition back to graduate school or switch industries and get into the neurotech industries. So when we went to develop our course on ethical considerations in neurotech, we had a goal. One was that it be a practical introduction that would be very palatable by engineers and hardcore neuroscientists, because we were expecting learners from multiple disciplines and varying perspectives. And we also wanted to train some kind of a skill. So I'll give full credit to Pauline and Jonathan Coutinho over here, who are have PhDs in neuroscience, but have both moved into policy. We thought, what kind of a skill could we train that would be related to neuroethics? And they came up with the makings of a neuroethical impact assessment that you could apply to a neurotech product or application. So in the course, we basically do an introduction to neurotechnology, analytical techniques, and basic neuroethical principles, because we thought it was important that everybody know what the tech can and cannot do, because not all tech is as ethically problematic as others. And then we do case studies in the medical neurotech, consumer neurotech, and organizational use of neurotech, or these dual use issues. And we have students try to apply this neurotech impact assessment tool to these case studies. So I'll just take you through briefly what this looks like. So in this, we felt it was important that you start by analyzing the technology. What does the actual tech do? And what can it not do? What is it used for? How effective is it? What are the physical safety risks? How much does it cost? Sort of that cost benefit analysis. And then the analysis piece, as you talked about, the importance of, is this being analyzed with an AI? How is this data being stored? Issues about data privacy and de-identification. How are the conclusions based on those analysis validated? And what are they actually being used for? And also then take them through what laws and regulations actually regulate the sale or use of this device and its related data. And go through then the ethical issues. How does this align with the principles of welfare, autonomy, justice? How does it potentially affect people's agency, data privacy, etc.? And furthermore, how might this change society? Because it isn't just the individual that might be affected by the advent of BCIs. You could have inequities, as you talked about, in access. There could be social pressure to use things that become evolved, like EEGs or Neuralink implants, if they ever become available. Also, there could be stigma or discrimination for having or having not have a BCI device. So the other feature of this is that we do a 2-week boot camp where students actually come on campus and they actually get neurotech workshops by academic and industry experts. They design their own project and present that. And along the way, we talk about neuroethical issues all the time. And this is done in a dedicated space we've built that has a variety of neurotech equipment. And we piloted this in May, and it was just a fantastic experience was had by all. The other feature I try to do throughout these courses is patient inclusion in the teaching. When I talk about cochlear implants. We actually interview people that have one and talk about what issues and how it affected their lives. Here's Ben Stecker talking about reprogramming his DBS device to reprogram his brain. We actually even have examples of patients leading research projects. And this is the case of Mark Macaulay, who is a DBS recipient from Australia, who actually came because he wanted to run his own research projects on himself. And he did that, and teams of students joined in to help him collect data on his own, on how modulating his DBS settings affected his gait and his brain responses. And there was huge teaching opportunities for this. We even presented it at the New York City Neuromodulation Conference. So just in the interest of time, sorry to have run through that quickly, but I want to end just talking about Connected Minds. This is a transdisciplinary training initiative that was funded by the federal government of Canada. This is a $105 million direct investment and a much larger funding envelope if we consider all the institutional and partner commitments. So just for those of you who are in Europe and whatnot, where are we? York University is in Toronto, and Queen's University is just on the other side of Lake Ontario in Kingston. It's a beautiful place at the mouth of the St. Lawrence River, and just not too far from Montreal, just to place us. So Connected Minds is at its heart a transdisciplinary exercise. We have three pillars: neuroscience, intelligent technologies, and society. Research projects that are funded by Connected Minds have to have an investigator team at the intersection of these, at least two pillars, if not more. The idea is sort of forced collaboration between people from things as far as the arts and theater, education policy and law, of course, collaborating with engineers and neuroscientists. The focus of Connected Minds, neural machines systems for a healthy, just society, is basically more or less on neurotechnology and AI. And the overarching research questions are really, what risks and benefits will modern technology have on society now and in the future? How is technology transforming society, and what are the future impacts on our health, culture, and communities? And finally, how do we balance technological progress and its unintended consequences for society, particularly for equity-deserving groups? So I want to highlight for trainees out there, if you're interested in coming to Canada, we have master's and PhD scholarships. These are deadline is coming up in January. We have postdoctoral fellowships that are quite rich, $70K a year plus an $8,500 research allowance. We take those applications in April and September. And of course, the multiple research grants that our members can apply for. The CFREF of Connected Minds basically operates as an internal granting agency. And I just want to highlight what trainees can look like in this. I'll highlight Jonathan here, who was a computational neuroscientist, who is now transitioning into policy and being co-supervised by a neuroscientist, a law professor, and a neuroethicist. We have an IP lawyer who's going to do a PhD in neuroethics. And the far end here, we have a filmmaker who's going to be talking about connecting minds through AI to understand familial trauma through complex art installations that are just mind-blowing. And of course, this is supervised by theater professors and a neuroscientist. So that's what the Connected Minds, the flavor of it is. I'm really happy to answer any questions about that. Oops. Oop, I'm going the wrong way. Here we go.
Thanks a lot, Susan. Oh, sorry.
Oh, sorry. And the final thing, of course, is that we have knowledge mobilization, which includes sponsoring the neuroethics, the BCI, the neuroethics panel at the BCI Society meeting in Banff, which I encourage you all to attend. Thank you.
Thanks a lot, Susan, for your presentation, for describing also your path and which are the Connected Minds initiative. So I will actually go through. First of all, I saw that Judy Ellis also shared the link of the International Brain Initiative that actually Marcello was mentioning during his talk. So I invite all the audience to actually have a look of this link. And then I would ask if there are some questions from the audience. You can actually unmute you and like ask the question directly if you want, if someone have any question.
So I see that Mariska has a hand up.
Okay.
But
Maybe
I
to-
will also ask my question since I unmuted. And I am wondering if either of the speakers has contact information that they would like to have shared with people who feel that they have been abused by brain-computer interfaces. Because I get calls or contacts of one sort or another like that with some regularity, and it would be lovely to have somebody to refer them to and to say, this is a person who you can talk to about the abuse that has happened to you because of brain-computer interfaces.
I can actually talk a bit about this potentially. In fact, we wrote this as part of this transdisciplinarity. When I was working with the people in the surveillance studies, they were very interested in this issue, and the fact that there are a number of people who believe that there's been that there has been some abuse on that side, whether it's founded or not. These people are in distress at some level, and all neuroscientists and neurotech people basically just ignore them. But is that ethical? That if they believe this, and it doesn't help that you have someone like Elon Musk saying that he's going to be reading from brains and that the technology is there and it's doing it, that it just sort of gives credence to their beliefs, whether they're real or not. So I do think there would be value in at least having some way to address their concerns. Mariska?
Yeah, thank you so much for these wonderful presentations. And I couldn't agree. You both made a point that it's so important for the developers and ethicists to actually start collaborating more to make sure that we're well informed about each other's perspective and can bring this this technology in the most responsible way forward. But I'm also wondering, and I think Susan, you have a wonderful example of how you've been doing that. But would you have recommendations perhaps for the wider field on how to do this better? Because most funding calls, they are very oriented towards either ethics or the development of the technology. So that makes it a bit challenging, perhaps. So any suggestions on how to make this, concrete would be, I think, appreciated.
Are you, sorry, speaking to me about that?
Well, I think to both of you, because I think you both were making that point. So if any of you had a suggestion on how to do that and how to, to do this better, basically for us neuroscientists, most of us.
Yeah, I think it comes down
helpful.
to education. I think people are taken off guard when they get those kind of emails from people. And as Judy pointed out, like, we're not physicians, and we're not psychiatrists, and it's not really our place to actually address these. You could refer them, but I'm not sure how most primary care physicians are going to know how to manage that issue either. I mean, one thing we brainstormed about once was about maybe creating like simple videos that could illustrate, what is and isn't possible with brain-computer interfaces, like that, to try to dispel some myths. I don't know.
Well, and I don't know if people would believe that, I mean, I have been told that the brain-computer interface was placed in somebody's cup of coffee and attached to every cell in their body, or that it was placed in their ear canal for the entire family, this one, which was a new idea, and that they can hear it turning on and off, and they can see flashes.
Right.
And it's like, there's something there that could be studied.
Well,
I'm not someone who could.
Exactly. So
I am an engineer.
Yeah. So I mean, I think this is where, again, transdisciplinarity would rule. You have maybe a neuroscientist collaborating with a psychiatrist who specializes in delusional conditions, and with an engineer. I'm not sure, but this is where I think we need to break down silos to have more people talk about these things together.
Well,
But
I have wondered about having a
it's a long
workshop.
line of this kind of thing, though. I mean, it was amalgam fillings in people's teeth that were carrying surveillance devices before this, and that it's just an ongoing continuation.
Well, I can reply to the person who was worried about the government reading their minds from satellites, because that's an engineering question.
Okay.
But, you know, some of the other things other than to ignore people, I don't know what to do. Telling them to go get help from some, you know, a primary care doctor, they've already seen all the doctors, and all the doctors have told them that it's a psychiatric, or I had one person who, you know, this implant is shielded from fMRI.
Mm.
And so, you know, there is a need there. And I was just wondering if any of you guys are studying it or even collecting these stories. It would give me somebody to refer, or to say, you know, you should talk to your primary care. And also, I know these people who are interested. But
Okay.
I think
so anyway.
That's very interesting what you say, because I think, like many issues, one way to address this problem is by collecting data and doing research. Because this is a phenomenon I think that we all experience. Everybody was in the BCI space, I think, is exposed to some extent to this kind of messages, but we don't have systematic knowledge about it. So I think we first of all would need to understand from what kind of individuals these messages are coming from, and I don't think it's uniform. There are certainly people with psychiatric conditions who do perceive this feeling of their brain being hacked exogenously, and often people with schizophrenia do experience that. But then there are also people who are psychiatrically healthy, but do buy these conspiracy theories that abound with regard to mind control. And as we know, we are in a post-truth era where conspiracy theories spread fast, and sometimes even main neurotech manufacturers like Elon Musk actively engage in the spreading of fake news. So I think we're also kind of part of this problem. And differentiating this types of problem, I think, is very important, because the conspiracy theory problem probably can be addressed using communication and public engagement and educational modules, like the beautiful modules that Susanne has presented. But at the same time, the psychiatric problem needs a referral to primary care. I think Judy is absolutely right that researchers do not have they're not in the right position to give advice, but the referral is extremely time consuming. I think I started doing that. So in my personal experience, when I started receiving this kind of messages many years ago, my first response was to refer them to primary care doctors in their specific area. But then it was just not manageable anymore, and it was impossible to answer all these queries individually. So I think we need to develop better solutions.
Well, I think that's really important. Everybody's getting these. No one talks about it. And how similar are they? Coming from the same group of people? Are they actually? We don't know, because nobody's. If people could collect them and we could analyze them, we actually proposed to do that in a grant that we had submitted that wasn't funded. Was actually...
I understand, but that raises an ethical problem, because how do we obtain proper consent? Because these people send emails, so in principle, we can use their data. We can do, like discourse analysis on the text.
That was the plan, was to see how similar they were, if there was common themes and messages.
Right,
but Zach's had his hand up for a long time. Zach?
Well, thank you, Susan and Marcello. And this is, hopefully a complimentary question, a fascinating conversation. Don't want to sidetrack, but I guess it's sort of building on the topic of neurodiversity and maybe plurality. I would love to know, what either of you think about, strategies for how to navigate the inevitable challenge that there's going to be a wide diversity of acceptable risk, conceptions of risk-benefit tolerability of different risks, a willingness to take different risks, and both between individuals and then across cultures, and how at what level is it instructive to impose normative guardrails or constraints on what levels of risks we're able to take, and at what level does a risk that an individual is able to take or willing to take actually have implications, ethical implications on other people societally in a way that goes beyond the individual. And I guess this kind of gets into dual use in terms of just capabilities existing and that being a broader risk. But anyway, yeah, the question is just on balancing the diversity and individuality versus normative approaches and guardrails.
Marcello?
Well, so what kind of guardrails do you refer to, just to get a sense of some concrete reference? Zach?
I guess I'm thinking in the context of medical BCIs and there needing to be a boundary at some point between a range of risks that will be determined to be acceptable to leave within the judgment of a user or their clinician to decide to take. And obviously in research, we have informed consent to help navigate that. But then, there will be some risks that, will be deemed, excessive or unacceptable for the entire population. And so, how do you distinguish?
Well, so this risk-based approach to technological safety is the approach, for example, the European Union is pursuing in the context of AI applications. So you might have heard of the EU AI Act, which is currently first and only attempt to produce a legally binding framework for AI. And this regulation is all based on this development of different categories of risks. And the highest category of risk is precisely called the unacceptable risk. So it's applications that are so risky in terms of severity, reversibility, and magnitude that should not be pursued under any circumstances. So, for example, they put under that category things like using AI for creating a social credit system or for known judicial face recognition. Can we develop a similar system for neurotech? Possibly. So, for example, some people would argue that some military uses of neurotech, for example, using BCI for offensive warfare, it's a kind of technology that we should not pursue under any circumstance. But then, of course, it's very important to determine how we measure risk, and of course, how do we enforce that? So, for example, I've been participating in hearings of the UN Institute for Disarmament Research, who's precisely scrutinizing the military uses of BCI. But then the problem is, how do we enforce this? What kind of instruments do we need to enforce this? I don't know, Susan, what's your take on this?
Yeah, I agree. I mean, at some level, there's going to be all these, global regulatory frameworks that will cover some of the most serious risks.
I think there's also a connected question to Zach's point, which is, should people be allowed to consent to unacceptable risks? So if people want to participate in experimental research and take the risk on themselves, should they have the right to do so? And often this conflicts with some ethical guidelines, such as the development report, for example. I'm a bit more libertarian from that point of view. I think if people are competent and they're making informed decisions, it's part of their cognitive liberty to also decide for themselves what's the degree of risk that they want to accept.
Yeah, thanks a lot. I have actually the last question before closing the talk. So, I mean, actually, Marcello, you mentioned also the UN, and if I'm not wrong, you are also an expert advisor to the UN on this topic. And I would like to, it's more a general question, like, how do you two like think that there is this perception also in this, because there are lots of new committee also in the national government and so on that are like related to AI and how to regulate the regulation for AI. But do you think it's like perceived more as an urgent need or more like prevention for a future thing? So there is this urgency that actually we are talking about like how patients feel when they have the implanted device and so on, or is more like, okay, yes, there is some in the future there will be this problem.
Well, so I think it's both. It's not a either today or tomorrow problem. So there are some issues that are already urgent today. I've tried to prioritize those, but of course there are long-term issues that are related to, for example, increasing our computational models for decoding mental states, or related to so Neuralink, for example, makes public claims about a future in which people have implantable BCI for non-clinical uses. So this is far-fetched, but I think it's important to do both urgent discussions, to address both urgent discussion and also long-term ones, because we also need what we call proactive ethics. Ethics cannot just be reactive, cannot occur after a problem arises, but needs to be preemptively address that problem in order to reduce the chances that it occurs. But of course, we need to be extremely clear about the time frame. I think that's an element of absolute intellectual honesty, because if we present problems in the far future as if they were urgent, I think we just create confusion, and this is what the media often do. With regard to UN, there are several organs that are operating in the neurotech policy space. So there is the UN Human Rights Council, which has recently produced a report on neurotech and human rights, which I encourage everybody to read. It was just released a few weeks ago. And then there is the UNESCO, which is producing a recommendation on the ethics of neurotechnology. And Judy Illes and myself are part of the expert group who's drafting that document together with 22 other experts. And it's now in the phase of open feedback. So it's been negotiated with governments, but also everyone can provide feedback. So I really encourage everybody to go see the document and give us feedback, because your expertise is invaluable to make sure that this is a document that is incorporating all the expert views on the topic.
And I think you're getting up a good point. We don't want these unfounded fears to then stifle innovation, because that goes against, as you pointed out before, that patients are waiting for some of these devices and they will reduce suffering. So delaying them based on unfounded fears is also a problem.
Yeah, no, that's actually true, and then actually that's I think like a good point to like highlight, and that should be addressed. And like, I mean, I think that it also is important to all the BCI experts and the BCI society itself as a society of people, of researchers working on that could contribute, because if like we are actually seeing every day like patients with different kind of devices and so on. So also like I think that like a feedback also of all the research group on that could be helpful also for like defining some guidelines in the government from a government point of view. Yeah.
Yeah, and I think including patients early in the research process and deciding what the research question is and deciding how they want, what would be a benefit is so important. And that's what we discovered. I mean, they have the best insight into what the issues are, and they can teach us so much.
Yeah, I think that like their feedback should be like the drive like all the research on which is they are their needs, or really like follow this kind of trend of more like personalized and like also speak with them which is the best and the worst of what they already tried in some experimental protocols and so on is really important also to drive a bit which are like the steps to follow to develop a new technology. Yeah, that's for sure. And there are actually now also a lot of BCI patient society. So there are like society of patients that can be also contacted for this kind of reason. So I think that now we are moving towards this direction.
Yeah.
So, I mean, I want to thank you a lot. I don't want to steal more time from you. So thank a lot for this insightful talk. And I mean, it will be recorded. So for the people that have to leave before, like, of course, they will not miss also the final part of the Q&A. So thank a lot, Marcello. Thank a lot, Susan, for being here today. And like, I hope to see you at the BCI meeting in person in Banff.